The problem name is remove stones to minimize the total. So the question is, you are given a zero indexed integer array piles where piles of I represent the number of stones in the ith pile, and an integer k. We can apply following operation exactly k times. The operation is, we can choose any pile of I and we can remove pile of I divided by 2 stones. We can remove half of the stones. And one thing is there, we have to see, that is, we can apply the operation on the same pile more than once. Like if we have removed 9 divided by 2 pile, and here we have we will put the remaining stones, then we can apply the operation on this position again that they have given. So what we have to do, we have to simply return minimum possible total number of stones remaining after apply key operations. Minimum possible total number of stones after applying key operations. So here one thing we have to just keep in mind, what if pile of I is having 4 stone. Okay, so we can remove 4 divided by 2, 2 stone, and remaining 2 stones we will put there only. Okay, but if pile of I is having 5 stones, then we can remove 5 divided by 2, 2 stones, and 3 we have to put there only. So we have to return minimum possible total number of stones remaining after applying k operations. What we have to do, simply we have to, I am repeating again, we have to return minimum number of possible total minimum, we have to return minimum possible total number of stones after applying k operations. We have to return minimum possible stones. So the the method of this question is, if we have to return minimum possible total number of stones after applying, so for minimum we have to do, we have to remove maximum stones. To return minimum total number of stones, we have to remove maximum stones. Like what I'm doing, what I'm saying, to to return for something, we have to return minimum number of thing. So if we have to return minimum number of this, then how it will minimum? If we will remove maximum number of stones, then we can return minimum number of stones. Okay, sorry, minimum number of stones. So the method of this question is, we will choose that pile of I which having maximum number of stones. At present, which pile is having maximum number of stones, I will choose that pile. So here in this array, 9 is having maximum number of stones, so I will choose it, and I will say I have removed 9 divided by 2 means 4 stones. I have removed 4 stones. Now the array will become 5, 4, and I have removed 4 stones. So now the remaining stones are 5. In our answer, in our temp or answer, I will store how many number of stones I have removed. Till now I have removed 4 stones. Okay. Now I will choose this 5 or this 5, any number of any of the 5, because they are similar. They are same. So I will choose this 5 again, and I will say I have removed 5 divided by 2 stones. Now the array will become 5, 4, and 3. I have removed 2 stones. So remaining stones are 5 minus 2 is 3. Also we have to keep the track of operation. How many times I have done the operation? I have done the operation here first time and here second time. So now k is 0. Now k is 0. So I can't do operation now because k is 0 now. Okay. So how many number of stones I have removed? I have removed 4 plus 2. I have removed 4 plus 2 is 6. Maximum number of stones in 2 operation I can remove 6. Now the total number of stones in beginning is 9 plus 5 plus 4. It is 18. It is 18. And I have removed 6 stones. So what we have to return? We have to return after remaining the stone, the total number of minimum total number of possible stones. So after removing, the result is 18 minus 6. I will say after removing 6 stones, The answer is 18 minus 6. So what we have to do, we have to remove maximum number of stones. We have to remove maximum number of stones. So I will take that pile which having maximum number of stones. Again and again I have to take that pile which having maximum number of stones. So I can choose a data structure priority queue. I can choose a data structure priority queue maximum heap, which will on the top I have which will take this condition. I want maximum number of pile, which I want that pile which having maximum number of stones. So I can use the priority queue max heap. So what it will do, it will simply return as the maximum stone. It will simply return that pile which having maximum stone. Again and again we will say, we will pop this, and we will remove half of the stones. We will remove half of the stones, and remaining stone we will put in this only. We will say 9 is popped, and after remaining, if it is greater than 0, I will say push it in the priority queue again. And this we will continue till the k is not 0 and this priority queue is not empty. So the code is, I have taken a priority queue of max heap and a sum will keep track of how many stones I have removed. I will simply I will simply run a for loop and put every pile in the priority queue. And I will no, this sum is total number of stones we having in initially, how many stones we are having. So I have find the sum, and I have put every pile in the queue. In answer, what I'm doing, I'm storing how many stones I have removed, and in a temp I am finding the top of the priority queue. What I'm doing, I am finding temp is the top of the priority queue and I am dividing it by 2. Now the top of the priority queue, now what I am checking, if remaining stones are greater than 0, if remaining stones are greater than 0, then I am pushing it again in the queue, and if they are not greater than 0, then I will not push. So, and I will pop the previous number which we have having. So in answer we are storing how many stones we have removed, how many stones we have removed. And I will say decrease the k by 1, because if the loop runs 1, then we will say I have do the operation first time, and I will decrease the k every time. Then what I have to remove, what I have to return, I have to return the remaining number of stones after applying the k operation. So I'm returning sum minus answer. We can run the code and submit. It's working finely.